Okay. Uh, Hello, everyone. I'm not sure how many of you has attended my presentation this morning. Okay, cool. Okay, and I think some of you are even haven't heard about Qinling before, because this is the first time to do the Qinling project update in a summit. So I will try to explain. I will try to introduce a little bit about the background of Qinling again, and also I will introduce current Qinling features that are implemented so far. By the way, my name is Ling Xian, and I'm a senior cloud engineer, cloud computing engineer in Catalyst Cloud. I'm also the current Qinling PTL. So as you know, Qinling is function as service in OpenStack. And I have already told the story this morning. Qinling was initially launched by Catalyst Cloud due to our customer requirements. And also, I think it was first introduced to the community, the whole community in Sydney Summit. And shortly after that, the project was approved as an OpenStack official project. So which means we will have the first official release this Rocky dev cycle. And currently, Catalyst Cloud and AW Cloud are the two main companies who have done most of the contributions so far. And we also have other contributors from FiberHome and Nanan Cloud, etc. But actually, we need more because, as I mentioned in the presentation this morning, there are still a lot of things missing to make Qinling production ready. This is current features we have implemented so far, some important ones. So basically, there are several resources defined in Qinling. The runtime, function, execution, job, webhook. The runtime is known as the environment in which the function is actually running. And currently, Qinling supports two reference runtime implementation, which is Python and Node.js. The Node.js is not fully tested for now. But actually, in public cloud or in production deployment, it's recommended that the cloud deployer provide the runtime implementation. Because I believe that as the most important part of function as a service, the cloud deployer or the operator, they don't want their own runtime to be open sourced. Although we provide the reference implementation, but in production, I recommend you implement your own. You just need to implement some interfaces so that the runtime can communicate with Qinling. The function is usually the actual code, but as I told in the presentation, there are three types of function. The code package function, which means you can upload your own code file or code package, depending on how many libraries you are using. And also, Qinling supports the Swift type function, which means you can upload or store your function codes in Swift object and invoke the function by specifying the container name and the object name. And also, Qinling supports image type function. So you can run your function written in any program language, but you need to provide your own image. When a function is invoked, there will be a new execution. So, and after the execution, you can query the log, and you can also query the duration and the output from the execution. And job is much similar to the cron job in Linux system, but it's much powerful because in Qinling you can define some function that could be invoked periodically, but just in a predefined number of times. Webhook is most important to the event-driven style. Because in Qinling, if you want to trigger some function, you need to provide your credentials. but the webhook provides a way for the external applications that can trigger the function without any authentication or authorization. So for example, you can configure a webhook in your GitHub repo and invoke the function if some event happens in your repo. Currently, Qinling supports a synchronized function execution and asynchronous execution. So for synchronized execution, which means the client needs to wait before they get the reply. And for asynchronized function, you can just trigger and forget about it. And later on, you can query the function execution result using Qinling API or command line. And auto-scaling. I showed a demo about auto-scaling feature just now. And currently, Qinling only supports a simple auto-scaling algorithm according to the request rate. So Qinling can automatically increase the workers according to the concurrency of your function execution. And also, Qinling supports manually scale up or scale down the function. Because sometimes maybe the container orchestration platform support more advanced monitoring capability, and you want to trigger the function inside the container orchestration platform. So you can just put your credentials and the function ID there, so the function can be triggered automatically by the underlying monitoring system. We also provide some useful actions for the admin user, the function detach and get workers, etc. The function detach is very helpful, either for testing environment or production environment, because by default in Qinling, if a function is invoked, there will be a worker or several workers allocated to the function, and they will keep running or keep alive for 5 minutes by default. But sometimes the runtime will be problematic. For example, due to maybe they are stuck, or maybe they met with some memory leaking issue, and we just want to get rid of the existing workers immediately, and a new worker will be allocated if the function invoked next. So in this situation, the admin user can just use the function detach functionality to remove the current workers allocated to the function. And so the underlying container orchestration platform will create new workers, will allocate new workers for the function. And of course, we provide OpenStack style command line interface, which is an OpenStack client plugin. In this dev cycle, there are several things we have accomplished. First is documentation. Although I said we still have a very poor documentation right now, but you cannot imagine how poor it was before it was announced as an official project. But we are trying our best to add more and more content, so the newcomers or contributors, they can see more details about this project. And function versioning. Actually, the versioning has been implemented, but according to the demo this morning, there are some bugs we need to fix. The function versioning allows the developers to update their function without breaking anything running in their either in testing environment, a staging environment, or production environment, because you can create different versions for a single function, and you can use different versions in different deployment. Previously, Qinling talked to Kubernetes API using insecure connection, but in this dev cycle, we changed that using certificate to communicate with Kubernetes API. And the resource limitation. Qinling supports a resource limitation before, but just a support to one resource limitation for all functions. which is not flexible, and it's not possible for the billing. So in this dev cycle, we allow the users to specify their resource limitation when they create their functions. There are still a lot of things we need to finish to make Qinling production ready. The first priority is always documentation, which is a thing that most developers don't like. But we are trying our best to add more. And also for billing purpose, we need to send notification to either Telemeter, or we could provide some plugin or posters for CloudKitty to collect metrics from Qinling. And function alias, after finishing the function versioning feature, I think the next one will be the function alias. So it could be convenient for the users to invoke the function by just specify a name they are familiar with, rather than a UID of the function. Function tag is used for grouping or filtering, especially for public cloud provider like us. We can use the tags to categorize our invoice for billing. And we also need a Horizon plugin. But the most difficult part for Qinling Horizon plugin is we need to provide a code editor in the Horizon. So the developer can develop their code in Horizon directly. If the code is very simple, you don't need some other libraries imported. And exception handling. We need to provide different type of retries or error handling for different type of function invocation. Advanced auto-scaling. Maybe in future, the auto-scaling feature may be refactored to support different types of algorithm. Maybe we can use pluggable mechanism to do that. And we also need to integrate with other projects or other communities, like what I mentioned this morning, the cloud event specification in CNCF Foundation, and integrate with serverless platform, which is a very famous platform to orchestrate your function definition and your and also the integration with API gateway or something else. And maybe in future we also need to integrate with other function as service solution, just below in the below part of Qinling. So that because currently, as I said, there are a lot of function service implementation in the container world, and for now we just support a different type of orchestration platforms. But maybe in future we could support other solutions like Fission from Platform 9, like FN from Oracle, and other projects. If you are interested in Qinling, please join our IRC, and I'm always online. And also you can send email to the OpenStack Dev mailing list. We already use Storyboard for the feature proposal and backtracking. And feel free to submit your own use case or if you find any bugs. Also, if you think it's not comfortable to send things in public, you can just send email to me personally. There will be a project onboarding session afterwards. And as I said this morning, I didn't prepare anything because I want to know more about your use case. Maybe you have some requirement, or maybe you are thinking about to provide such service in your cloud, so we could chat. Yep, that's all. Thank you.